types of text analysis in R from my experience in research, but yesterday I was playing with some data that hopefully can talk to you, can be more related to you than what I did. First, why do we want to analyze text? Uh, One of the reasons can be that we either can't read that much or won't read so many volumes of text as much as we need to. Another reason could be that even if we read a lot of documents, it can be books, it can be scientific articles, it can be any type of document, we won't necessarily remember everything that we read, and we need to synthesize all the information. Sometimes we cannot do that only by reading. Uh, and the other reason is that we may want to increase objectivity and let the data tell the story. And I put the increase in italics because I think that we can never achieve complete objectivity even if we do data analysis, quantitative data analysis of text. And we can always be maybe less biased by a quantitative analysis. However, it's not just the data that tells the story, right? We ask questions. There are some things that we want to look at, and we control how we want to look at things. So we can analyze text to help us get information of enormous volumes of text. We can try to increase objectivity, but we also have to be aware that it's not completely objective. So these are the reasons why we would want to analyze text. And now let's go to what type of text analysis we can do. And I'm going to explain a few things here. I cite some of the things that I think are the most common, but I'm not an expert. I just learned to do this for one of my research projects. So do word frequency, word clouds, topic modeling, and sentiment analysis. So word frequency, right here I show an example of a bigram frequency of, that's Harry Potter and the Sorcerer's Stone. And bigrams are sets of two words together. So this is like the frequency of how repetitive are these two words together in the text. So these are the kind of things that we can analyze, word frequency. The other thing is that we can do word clouds. And again, these word clouds can be a representation of anything. And I'm going to show some examples of word clouds where we're going to give more weight. So increase the size of the words proportionally to the frequency of those words in the text. So we can see through the word clouds which words are the most important ones. Another type of analysis is then topic analysis, as mentioned in the introduction. So I'm going to give an example of what could mean topic modeling without going into the details right now. So the example that I could think of was the question, maybe why would I attend the Data Fest? And I just took some phrases that I read in the Slack workspace that I thought could, be examples of people's answers to this kind of question. So an answer could be, I want to meet people from the data world. Another answer could be, I want to get insights into the intersection between data and democracy. Or I want to learn from and with the Data Fest community. Those could be kinds of answers to a questionnaire on why to attend the Data Fest. And as you see, I highlighted a few of those words within the answers that could reveal some topics within people's answers without saying that they're talking about these topics. So these topics could be networking and learning. And we see some of these words again. So meeting people, world, data fest community. Those words say something about people's interest in networking. But then we have insights or learn, which are, well, related to learning. So you can see that within these three replies, we could intuitively see at least two topics coming out of these answers. And in one case, in one of the examples, we have one answer that refers to the two topics. So this is the kind of thing that we try to do with topic modeling. We analyze some text and we see that within this text, there are some hidden topics and we try to identify them. That's what we are going to do in our example of topic modeling, and I'm going to show you how to do this with R. Then we have sentiment analysis. This is not something that I'm going to show because I haven't really done it deep enough to be comfortable with explaining exactly what are the biases in the models and so on and so on. So I'm just going to explain you the idea of this in case you don't know. And I took a couple of tweets about the data fest to give an example. And I didn't show the names because I didn't ask for permission for people to show their tweets here. So one of these says, "Thank you for sharing your design process. It was super valuable, especially for beginners in design and development like myself." And you can see I highlighted a few words that are related to positive comments about the data fest. So you can see that this is a positive tweet, right? It says thank you. Thank you is usually positive. Sharing as well. Super valuable, that's very, very positive. We have another tweet that says, really enjoying Sensahan's, sorry if I'm butchering it, talk on how to use AI and automation in journalism, data festibility. Some of the points Uli makes around using AI and automation in journalism around pain points and making reporting more broader and deeper is essential when using these tools in journalism. So again, we see that this is a positive tweet. Enjoying is a very positive word, essential as well. So this is the kind of analysis related that is called sentiment analysis. It's about identifying words and if they are positive or negative, if they are conveying positive or negative emotions or reactions, and what usually happens is that people that do sentiment analysis, they use something called lexicons, which is kind of like some of you may know this more than me. I'm just assuming that some people don't know, so I'm just explaining. Um, Lexicons are like kind of like dictionaries where you have a score of positivity or negativity associated to words. So you can use that to process your text and see how positive or negative is, like a brand, for instance, or the opinion on an institution, or a data fest or something. And you can score the tweets. You can score one brand, one product related to, associated to the tweets or any text you want to analyze. So the lexicons are key, and if you have questions later about that, we can talk about that too. So this is sentiment analysis, and again, I'm not going to show any examples on this one, but I'm going to show examples on the other ones. But there is a book called Text Mining with R that talks about all of these things. And I invite you to look at it, and it also covers sentiment analysis. Okay, so before we go into the actual analysis that I mentioned, we need to talk first about data processing. And so data processing is important in any data analysis, in text analysis as well. It's very important, and it could be a pain in the ass as in normal data analysis. So we need to clean the data in order to analyze it first. And I just mentioned here in the slides a few important things that we need to do while data cleaning, but that will also depend on the text that you're analyzing. And maybe you should do more things or less things. For instance, remove redundant words. And sometimes we have words that are not informative at all. Like I just said, informative at all. If we analyze this phrase, actually, informative may be the only informative word. At all may not, at and all may not add any information to an analysis. So when I say, I did uh, amazing cookies, I baked amazing cookies, probably I is not an informative word. Uh, if you want to do great text analysis, depending on your objective. So some of the words, you just want to filter them out at the beginning, and that's a process we need to go through. The other thing is that if you're analyzing text that may be written in, we're talking about English right now, so um, some of the text may be written in British English and others in American English. And like if you want to count, for instance, the frequency of words, maybe there's a word that's written color, like COLOR, and the other one is color, COLOUR, depending on if it's British or American. And if you don't standardize the English, you're going to count them as two different words, and it's just one word. So you want to standardize the English if you know that your text is going to be written in these two different styles. The other thing is lemmatizing. So lemmatizing is, I don't, I may not be using the right linguistic terms, but it's about finding the right, not exactly roots, but like semantic roots of the words. For instance, um, you have good and better, but good and better may mean something, may mean the same thing. So if you lemmatize, you're going to see them as the same word. And sometimes this is what you want. Other times you just want to see the roots of things. Like when you say, when you see the word study and the word studying, you may want to consider those as just one word. So just finding the root of the word would be enough. So in my case, I had to go with lemmatizing for my different applications. And the other one is to filter out words with very low frequency. And we do that because if we're modeling at the end, we want to introduce less noise to the models. So if we have just one random word in the text, it's just introducing a lot, like a different term or a lot of different terms that are just going to make noise. The model will not be able to fit to it. So this is the other thing we need to do first. And now, after all this explanation, I'm just going to show you how to do this with R. And I, when I wrote the abstract of the talk, I thought that I was just gonna go through the example that I work with, movement ecology, and I will if we have time. Uh, but I thought that we could start with an example of tweets about data festibility. So first of all, we're calling all the packages that we need and the auxiliary functions. So I'm using tidyverse, uh, like several tidyverse packages. So I'm calling the whole family of tidyverse to be quick. A few packages related to text, so tidy text to manage the text. string R for a few functions there, TM, which is text mining. I used it to remove words in Spanish. In some cases, we don't need that. Text stem, I use this package for the lemmatizing part that I just explained. For this example, we're also using our tweet to be able to download the tweets. GG Word Cloud, I'm going to explain later why I prefer this package for the word clouds. And then topic models for topic modeling. Okay, so here's my path to some of auxiliary functions that I'm using. And I'm using two functions that I wrote that we're going to see one of them in a bit. One of them is Americanizing, and that's the kind of like dictionary from things that I found online that are like, I think it's like 4,000 words that have like, so I have them in two columns, like the British way and the American way. And in that, and I wrote a function to look at this file. And like, if I want to standardize everything in American, I just look in the text, recognize these words written in British, and then I transform them into the American way. Or I can do the opposite. So that's Americanizing. It's so simple that I think we don't need to see it, but we can if you later want to. And then there's cleaning words abstract, which is my function to clean words. And because I started analyzing scientific text, I was analyzing abstracts of scientific papers, and that's why it's called cleaning words abstract. Okay. So after calling all of this, now before using the RTweet library, you need to create a token to be able to download tweets. I have a link here, but of course you're not seeing it. So in case you want to see that, I can put that in the chat right now. So this is a guide to do some text mining. Can I write in the chat? I don't know if I can. Wait, yes, but the link did not copy. So this is a link to be able to mine text from Twitter. So it introduces you to how to create the token if you don't know how to do that. Um, so anyway, I created it, and I used one function in R to make the link uh, from my token from my Twitter account and access to R. So after that, I use the function search tweets from the R tweet package. And I want to search tweets that say DataFest Tbilisi, a maximum of 1,000 tweets. And this function allows you to get tweets from the past 6 to 9 days. And I said include retweets true. So I downloaded those tweets and saved it in an R object called df Tbilisi. If you use this, you're gonna see that there are so many fields. Like you get a data frame with so many columns that it's just too much. So for our own interest in this example, we're just gonna keep the actual tweets and the ID of the tweets. So the tweets are in a column called text, and the IDs are in a column called status ID. So we just keep those two columns in data a data frame called text_tb. And then on text_tb, we use the cleaning function. So we're gonna say cleaning words abstract text_tb, and then the other argument of the cleaning function is to specify where my tools for text mining are, and I said they were in my auxiliary text mining path. So these clean functions, this clean data frame is saved in df words. So of course, it would be better to take a look at the cleaning words abstract function So we're gonna take a closer look, and I'm gonna open it in R using R Studio. I am going to make the font size bigger, just to make sure that you can look at it. Okay. So this is what my cleaning function looks like. All I need to do is to specify again the data frame with the tweets or the text, whatever text I want to analyze, and then I put the path where I have my auxiliary functions. Then the first thing that the functions does is to separate the text. It says again everything where it says abstracts is text. To separate the text by word. So I use the function and nest tokens, and I say, okay, I want to get a data frame with a column called word. What I want to separate, so the input is going to be text. And the token, the type of unit in which I want to separate are the words, and the format is text. So I use that to separate the text by word. Then I use this function, anti-join stop words, to remove all the English, non-informative, redundant words. So this is an advantage to analyzing text in English, that there are so many tools to analyze text in English. So I use this function to remove English stop words. Then it doesn't remove every stop word that I want to remove. So I manually remove other words that in practice I have seen for my cases of application that these were not informative words. So I just created a vector of non-informative words. And I added a few ones for this example. Then I remove these words, again with the anti-join function. Then I wanted to remove numbers from words because I also deemed them uninformative. So to remove numbers, I use the string_r function called str_detect. And this is the way to express that I want to remove everything that is not characters. Alphabetical characters, and then I remove them. I'm also assuming that everybody is familiar with R, but if you have questions or want me to stop to explain something, please put that in the chat. Then I remove other abbreviations that I think are uninformative, like EG that you always use for examples, or IE to say, oh, I mean this, with the same kind of code. And then there were a few things that I added based on my experience and working again with my movement ecology application, because that's the field that I do research in. So I just want to say that km was kilometer, because in some text it was written km and in other kilometers, and so on. After that, I use my dictionary, the one I told you about, with American words and British words. And then I homogenize. So once I open the dictionary, I use the Americanizing function. So I convert everything from British to American. And after that, so these words converted to American are going to be stored in my df words object, which now has every single word separately in a different column called word am, so word in American. Then I lemmatize the words with the function lemmatize words from one of the packages that I already mentioned. And these lemmatized words, I store them in the same data frame, this time in the column called word am lem. So this is the Americanized and lemmatized version of the word. Then a few other corrections because the lemmatizing is also a field of research. So there are algorithms to lemmatize, but they're not perfect, and different people have their own styles. So there were some words that I still wanted to put together. So I did it manually, like behavioral, behaviorally, behave. They all meant behavior for me. Move and movement were the same, datum and data the same, and so on. After that, somehow I still had some numbers put together during the lemmatizing, so I removed numbers again. And then this is not a problem with the tweets, but for my own research, because I was researching about papers in the US. A lot of places in the US have Spanish words, Spanish names, um, essentially the places that used to be part of Mexico. And so I wanted to remove some stop words in Spanish as well. So I put that in the function. And that's it. So that's what this function has, all this cleaning. And again, the cleaning depends on your case of study. So um, once I use the cleaning words abstract function, I get this kind of data frame. So this is the head, the first lines of my new data frame that has been cleaned and processed. So what we have is a tibble, a data frame that has column as status ID. So this is the ID of the tweet. Then the other column is word. So this is the words that were separated. Uh, and then the American version of the word, well, in this case, those are exactly the same, right? And then the lemmatized version of the word. And again, in these examples, they're almost the same, except that rights is lemmatized as right. That's the only difference. So this is the kind of result that we get, a data frame with, of course, a lot more rows and one row per word per tweet. So now that we have cleaned our data, we can calculate the word frequency. So this is how we are counting and taking relative frequencies. We have our data frame that I just showed you, and we are using the function count to count uh, the uh, Americanized lemmatized words. And then we stock this count in a data frame called word frequency. We do something else to this word frequency. Once we have count them, and when we count, we get the count, we get it automatically in a column called n. So what we're going to do here is we're going to generate a new variable that is called prop. So it's going to be the proportion. We don't want just the absolute number. We want the proportion of this word. So this is going to be n divided by the total number of rows. So we get the proportion, and we also decide to arrange or order our data frame in a descending order based on n. So we do all of that to word frequency, and we call it again word freak. And when we see the head of word freak, we see the most popular words in the tweets, which are data, data festibility, talk, track, speaker, and meet. And these are the counts and the proportion. And I think that we had maybe like 200, around 200 tweets. Yeah. So this is the word frequency. Now we can make a table, for instance, of the 8 more popular words. So the only thing that I'm changing here is that I'm adding one variable that is the percentage instead of the proportion of the word appearance. I just use the percentage, which is proportion times 100 and then rounded at 2 decimals. And then I'm just showing the word and the percentage and the first 8 words. So this is the result. We have the words, n, and the percentage. So this is the word frequency. Now let's make a word cloud. We're going to filter again on frequency. So in a word cloud, we can choose to put every single word that we found in the tweets. Of course, we clean the redundant words, right? But we can choose all to show all the clean words. However, it's very hard to read every single word. People are going to try to read every single word when they see them in a word cloud. Sometimes it's very hard because they're going to be tiny. Again, we're going to want to represent them uh, proportional. Their size is going to be proportional to the frequency of the word. So if the word was just used once or twice, it's going to be very difficult to read them and maybe unnecessary. So we're going to filter based on frequency first. And here I just added an arbitrary uh, filter. So I said the words that appear more than 5 times in, in the tweets in general. So this is what I get. And I call it word freak most 2. So I'm using ggplot this time on word freak most 2. So the label, the text that is going to go in is the word that is Americanized and lemmatized. The size of the word is going to be proportional to prop. So prop is the proportion, the relative frequency. The color of the word is also going to be in a scale that depends on prop. And then I'm going to use this function, which comes from the GG Word Cloud package called geom text word cloud area. I'm going to put eccentricity equal to 1, which means that if you get a word cloud, instead of an ellipse, I want like height and width to be proportional in a ratio of 1. So it's more like a circumference than an ellipse. Yeah, so why to use GG Word Cloud? Because with many packages that also do word clouds, we even when we try to use to represent words proportional to some variable, like the frequency of the words usually, sometimes a word can seem bigger because it is larger. So what most packages do is to represent they say the font size proportional to frequency, let's say. But if you have a word that is, for instance, data stability, if you have that whole thing as a word, it's going to look a lot bigger than a word with the same frequency that is just data, because it's a shorter word. What this package does is to make sure that not only the font size is proportional to the frequency, but also the surface, the area of the word in the word cloud, and that controls for the effect of the length of the word. So that's why I'm using this package. I use that function, then some other parameters just for aesthetics, including the colors that I manually picked, the scale of colors. I also played with the margin of the plot and the background and so on. So after using this function, I get a word cloud like this. So these are the words that were repeated more than 5 times in the tweets. And we see that the word that is highlighted the most is data, then data Tbilisi, talk, track, speaker, meet, design, workshop, visualization. Then you have join, human, AI, journalism, write, hold, Tbilisi, and so on. So these are the words that represent the tweets of DataFest Tbilisi. So now we have our word cloud. Now let's see how to do topic modeling. Topic modeling is, again, like any type of modeling, there are several ways to do it. And there's several types of models. Here I'm showing an example of the latent Dirichlet allocation models, so LDA. These are basically Bayesian mixture models. So I'm not going to go into the details unless you later have questions about this. But basically, as I showed in the example of why to attend the Data Fest, we think that there are hidden topics in the text. And we need to uncover them. And the words within the text give us clues on which are the topics. So something that we need to know is that we are going to fix the number of topics. So we are going to say to the model, we believe that there are 2 topics, please find them. Or we believe that there are 4 topics, please find them. So the model is going to find some topics based on the words. So what is important to take into account is that the concept of a topic is that is something, a theme, a subject that is composed by a mixture of words. So as in the example that I gave, so the topic network could be composed of what was it? Community, world, meet people. So these are words that would have a lot of weight in that topic. um, then, so each topic is composed by a mixture of words. Then each document, in this example, a tweet, each document is composed by words, right? Each document is a subset of words. And it's also composed by a mixture of topics. So a tweet can talk about 1 topic, 2 topics, 3 topics, we don't know. If we fix the number of topics, then if the number of topics is n, then a tweet can have a maximum of n topics. It can have 1 topic, 2, or so on, a maximum of n. So this is the idea behind the model, that we have a fixed number of topics. Each topic is composed by a mixture of words. So behind it, there's a probability distribution of the words. So a word that is highly related to a topic would have a high probability of appearing if we're talking about this topic. So if we're going to talk about networking, the word network or the word meeting people or the word community is going to have a high probability of appearing in the tweet. Yeah, so I'm not showing more details about the exact, like the mathematical composition of the model, but I can talk about it later if you want to. So now, the thing is that I tried to identify topics in the tweets about DataFest Tbilisi, but honestly, there were a few tweets that we extracted, and the topics did not disentangle so much. So I decided to look into another data set, and this time I decided to extract tweets about Tbilisi. So here we do the same thing, and I'm not gonna show the process again because I just explained it. We're gonna search tweets now just about Tbilisi. I increased the number a little bit, included retweets, and because we are going to analyze topics, and we want to make sure that we have relevant words and that we can interpret them and so on. This time we're just going to download tweets in English. So we do that. Now our data frame is Tbilisi. We have 1,099 tweets. Remember, this is from the last 69 days. We do the data cleaning, so we select the text and status ID columns. So status ID is the tweet ID. We use the cleaning words abstract function. So we clean the words. And then, yeah, we reduce some noise for the model, first we filter out the words that appear only once through the data set. This is something I mentioned before. We need to only include words that are going to some information into the model and not just put some noise into it. So this is the way we do it. Here I just identify the words that had a frequency of 1, and then I extracted them from the data set. And then I decided to exclude the word Tbilisi because if you remember, the search in the tweets are for tweets that use that word, which means that every document in the model is going to use that word, and that also increase noise into the model. Like every document is related to this word, so why using it in the model? So that's why I excluded the word Tbilisi from the models. And I use exactly the same code, except that here I identify the word Tbilisi and then I extract the words that have that. So now we give the data the format that it needs to do the topic modeling. Here I count how many times a word appears in each tweet. So before remember when we were doing the word frequency, we were counting how much a word appears in the whole set of tweets. Here is how many times a word appears in each tweet. So that's why I use the function count, and we're counting the words in a combination of word and tweet. So we're counting the words in each tweet. And if we see the head of this new data frame, we have status ID, the word, and the times the word appears in each tweet. Most of the times it's just 1. And once we did that, we transform this data frame of counts into a document term matrix class, because R has its own way to interpret every single type of object and does analysis depending on what type of object we have. We have to tell them now, hey, this is the document term matrix object, so you're going to do this type of text analysis that I want with this object. So the way to do that is to use the function cast DTM, where we say the document is status ID, the term is going to be what we had in column word AMLM, and the value, which is the frequency per tweet, is N. And we call this data underscore DTM. And now that we have that, we can do the topic modeling. So we're going to feed an LDA, latent Dirichlet allocation model, this time with 4 hidden topics. Remember, we have to fix the number of topics, and we use the topic models package. So we use the function LDA from the topics model package. So we do LDA, X is going to be data DTM, so our data in the document text matrix object. K equal 4, so these are the hidden topics. And then we put an initial value of one of the key parameters. So yes, oh, there's a question. Yes, this is yes, you can see as a clustering algorithm. It's similar to Gaussian mixture model. Similar because it's not Gaussian and it has layers of priors. So you can see it as a multinomial, right? Because you don't have variables that are continuous and that you expect a Gaussian distribution. You expect a multinomial distribution because you have your variables have their values are different words, so different categories. So you use multinomial distributions and priors that are Dirichlet. That's why it's called latent Dirichlet allocation. And if you have more questions about it, we can go back to it. So this is the way that we fit the model. It's very simple. programming wise. So we do the LDA. Normally what I do is to run several times the LDA because of numerical optimization, and I get the one that maximizes the likelihood. Um, but in this case, I'm just doing one for the demonstration. And we are storing this in an object called res1. So this model is going to estimate the parameters, right? What we do with a model function in R is to estimate the parameters of the model. And one of these parameters, one output of this model, is the estimated distribution of words per topic. And this is called beta in the outputs of the model. So we're going to use these values, these beta values, to create word clouds per topic so that we can interpret the 4 topics that I asked the model to identify. So we do this with first extracting the beta output of the LDA object. This with the function tidy from tidy text. So I just put the model output, and I say I want to extract the matrix beta. So we extract beta in a papers beta object, and the head of this object is a table with a column called topic. So these are the hidden topics, the terms, and the beta. So beta is basically the estimated probability that this term would exist given that we are talking about topic 1. This is in the second row, this is the probability that this term would exist given that we're talking about topic number 2, and so on, so on. And in some cases, this probability is very, very low, which may mean that the word is not highly associated to any of the topics. But in other cases, it will be well, it's not that low for 4. But in other cases, it will be very high depending on how associated the word is to the topics. So we're going to use that information for the word clouds now. So the first thing is that I created a new column called topic lab, which is just a factor of the topic column before. The topic column wasn't numeric and I want a factor, so that's why I created that, just for the plot. As in the example before, like the one from DataFest Tbilisi, where I mentioned that we had to filter out some words to not show a gigantic word cloud with some words that you can read. We're going to do that here too. In this case, I'm going to introduce an arbitrary threshold value to the beta value. So we filter out the betas that are lower than 0.003, and we stay with the ones that are greater than that value, and those are the ones that we're going to use for a word cloud. We use the function ggplot again. So from topic sample, we want to use the labels. Those are going to be from the column term. The size of the words are going to be proportional to beta, the color as well. We use again the geomtext word cloud area function, eccentricity around 1, all the aesthetic parameters that I talked about before. And then here we use the function facet wrap around topic lab, which means I want 1 plot per topic. So we use all that and we get this word cloud. We have, again, the 4 topics that were modeled with an LDA. So you're going to be better than me, the ones who live in Georgia, to interpret the word clouds. So if you see something interesting, please put it in the chat. What I see is that, so again, the most important words, or the words that are mostly associated to the topic, are going to seem higher, are going to look, bigger in the word clouds. So we see, for instance, that Georgia is very big in word clouds 1, 2, and 3, and a little bit in word cloud 4. Uh, so what you want to do is to focus more on the bigger words, and the other words help you with context, right? And of course, a word can be associated to all of the the topics, because that's how the model was written. So we see for me, the first word cloud is more about the relationship with other countries, and in terms of transportation, commerce, and so on. The second word cloud is mostly related to traveling, and maybe ideas of how you would try to promote visiting Tbilisi in Georgia. The third word cloud, uh, this word is Tbilisi in Georgia, right? The third word cloud seems to me more like um, uh, everyday topic, an everyday topic in Georgia. So it's more like it talks about child picture. I read a little bit about relationships with Armenia and something to do with energetics. Uh, there's also election, crisis. There are several with expressions with Dynamo, and I think that's the soccer team in Tbilisi, if I remember correctly. So this seems to me more like everyday subjects in Georgia. Um, and then we have a fourth one, which I interpret more like events in Georgia, and like times of events, conferences, uh, and reasons why to like data fest, technology, and so on. So of course this is not completely clean, but this is what the model identified when I asked to see 4 topics of the in the tweets related to Tbilisi. So this is how we interpret the topics, right? It's like, as in the question in the chat, this is like clustering analysis. When you do clustering analysis, the model doesn't give you the labels of the clusters. You have to interpret them based on the results. And this is a way to um, represent the results in order to interpret them. So I did a review of what was going on in this field that I work on, movement ecology. I used to work in fisheries, so when I started there, I was like, okay, I want to know what's happening. So movement ecology is basically whenever you tag animals, so you put a GPS on an animal or a person or whatever, and you can track their movements. So it can be GPS, accelerometer. People use Fitbits. That's also in a way movement ecology, because you want to know what happens, like why do you exercise, and if it's like in a different context and so on. So I wanted to know what had happened in the last 10 years, but that meant reading thousands and thousands of papers, and again synthesizing something that I think my brain couldn't handle. So I did data collection as downloading papers and extracting the text all in R. So I had to do first the definition of what I considered a paper in movement ecology. It wasn't like the tweets in which I said, oh, let's take all the tweets that say data festibility. Sometimes a paper is doing movement ecology without saying movement ecology. So I had to come up with different keywords and combinations of keywords to extract the text. So I did a little workflow to make sure that I was using the right keywords, and also doing quality control for that, to make sure that I was actually getting movement ecology papers. So this is what I represent. This is on my website. So I did the whole method section basically on a website form. So this is what is a movement ecology paper. And then of course I had to filter the results in R, quality control. And then I downloaded the manuscripts and luckily, there are some packages that make your life easier if you still want to do everything in R. So I used the full text package that allowed me to download the papers just using R code. Of course, in some cases, depending on the publishers, I needed to have an API. And if my university had some kind of data and text mining agreement with the publishers, it was easier. There are some places like Plus One is open access, so you can download everything without any problem. And it downloads everything in the right format. So this is the other thing, because I mentioned that at some point in the talk, I mentioned that I analyzed abstracts, but I also wanted to analyze the material method sections of the papers, because one of the things that I wanted to check is if they used which kind of software they use for the analysis, or what kind of GPS device they use in the analysis. So some of most of the time, these things are not in the abstract, and they're in the material method section. So I wanted to extract this section of the paper, and the papers were downloaded in two formats, either XML or PDF. XML is just a pleasure to work with because everything is just so in a hierarchical way, and like you use children-parent relationship to know where the title of the section is and where is the text, and you can find very easily the material method section. Um, so if it's in XML format, again, this is a workflow that I developed that is very easy to identify the method section, even if in different journals it has a different name. But if it was in PDF format, that was really, really horrible, because in some cases, I don't know how many papers of how many journals have you encountered, but in some cases you have two columns, like science has sometimes 5 columns. In some of them, you start with title, then abstract, uh, author affiliation, then abstract, then the 2 columns, and then you break into another page, and then the 2 columns. In others, you start with title, then a column for authors, then a column for abstract, then you break columns differently, and then you start with the text, and so on. So it's just horrible. And when R reads the text, it reads it like the 2 columns as if it were 1 column. So you need to write some code to separate between columns, then put them together in the right way to make 1 column that makes sense, and then find some way, somehow find the material method section. So I wrote a code for that, which is not perfect, but it was was working pretty well. And all the codes are in the website as well. So if anyone is interested, you can click on it and download the codes. So that was, again, data processing for that part. And then the data analysis. So this is a table basically on which type of data analysis made on which section of the paper. So the topic modeling in this case was done with the abstracts, because I thought that in the abstract there was enough information to distinguish topics in the papers, like it should be a summary of the paper, right? Then I wanted to know which species were studied in the papers, and I also thought that it was either in the title, keywords, or abstracts. I'm not going to talk about this framework. This is very particular to this type of study. Devices, if people use GPS, if people use accelerometers, and so on. Also looked into titles, keywords, and abstracts, but also material method section, which software people used. Again, in every section of these, and methods the same. So depending on what question, I analyzed a different part of the text. And then there was the topic analysis. So here I present a bit more detail on the models. I also, I do a schematic representation. the pre-processing part that I already explained, the model outputs with a bit more detail, and these are the word clouds. In this case, I used 15 topics. And I think that I didn't discuss the number of topics because, of course, this is a choice, right? Like, you can choose 3 topics, or 4 topics, or 5 topics. I think that there are a few metrics to select the models in a more objective way, but the metrics, in my experience, tend to give you like the optimum number of topics that they give you can be very large, too large, that you cannot really interpret these topics. That they are so specific that you really, there's nothing that you can humanly interpret. Um, so that's because the text is very complicated, so the model optimizes that way. So in my experience, it's best to pick the number of topics that you can interpret. And in this case, we saw a topic that talked about foraging behavior. So it talks about prey, behavior, colony, uh, predators. And then you have another one like 12, which is like birds, migration, flight. We also have, as I said, also human movement, and we actually found a topic about players, training, speed, team, match, distance, performance, and so on. So we have very different topics here, with that gave kind of like a snapshot of what was being done in the field, which is something that topic modeling can give you. And then some of the other analysis, and maybe the only thing that I will show here that could be interesting is that, at least in this field, we found that R is the software that is being like increasing its popularity throughout time. So this is the last 10 years that I analyzed. And these are the main software. I analyzed a list of 33 software in this field, and all the main ones are decreasing their use, and Python is not even there between the first 5, and R is steadily increasing. So at least for that field, we're expecting R to become even more popular. I think that's it.